So in this video, I would like to introduce methods of balancing redox reactions. Methods of balancing redox reactions. So methods of balancing redox reactions, redox processes or redox reactions. Especially or particularly, I would like to introduce two methods. The redox reactions can be balanced by two methods. One is oxidation number method. Oxidation number method. Number two is that ion electron method, which is otherwise called half reaction method. So these are the two methods we use for balancing of redox reactions. In acidic medium or in neutral medium and in basic medium. As you know that the chemical reactions carried out in acidic medium H plus ions and in basic medium OH minus ions and in neutral medium H2O. So how the redox reactions can be balanced? So let us discuss with the example. One example we'll take. First, let me discuss about oxidation number method. So by using oxidation number method, how the redox reaction can be balanced. By taking one example, we'll take this example can be K2Cr2O7. The potassium dichromate react with sodium sulfite in acidic medium reaction. Then potassium dichromate produce chromium plus 3 ions and sulfite changes into sulfate SO4 minus 2. So when potassium dichromate react with the sodium sulfite, produces chromium plus 3 ions and sulfite ions changes into sulfate. This reaction is carried out in acidic medium. So write the balanced net equation okay. So in this reaction, in this chemical reaction, so we follow 5 steps. 5 steps will follow. So step 1 to step 5 will follow. And finally we get net ionic balanced equation we get. So how we get now, let us discuss. So generally the chemical reaction, the redox reaction is given. So the step one we should write the chemical reaction which is carried out acidic medium, write skeleton ionic equation skeleton ionic equation by mentioning formulas of reactants and products we have to mention. That means skeleton of ionic equation we should write in step one by mentioning the formulas of reactants and products which are taking part in the reaction. For example, potassium dichromate and sodium sulfite. So since potassium ion is a spectator ion, so need not to mention. So first you write skeleton ionic representation of the reaction. Cr2O7 - 2 dichromate ion aqueous solution combining with the sulfite ion -2 with aqueous solution carried out in acidic medium. So chromium changes into chromium +3 aqueous solution plus it changes into sulfate -2 aqueous solution. This is the skeleton ionic equation. So mentioned with the correct formulas. Once after getting the step one, the correct formulas of reactants, reactant species, these are product species we got. So after this we should go for step 2. So step 2. So what happened in the step 2, what we have to do? So once after writing skeleton ionic equation, in step 2, find out oxidation numbers of each atom of element in ion or in molecule. So find out oxidation number of each atom of the element in ion or molecule. That means determine oxidation number of each species in the skeleton equation. So let us write Cr2O7 - 2 plus SO3 - 2 changes into Cr +3 plus SO4 - 2. This is the ionic equation. So aqua, right. So after that, so find the determine oxidation number. Chromium in this dichromate, the chromium oxidation number is, so how much? +6. So already know that oxidation number is -2. So which is same in all these oxygen atoms. Okay, -2 is oxygen, and sulfur oxidation number here. So -2 into 3, 6, and so here is oxidation number of sulfur is +4, and chromium is +3. Sulfur oxidation number changes how much? +6, and oxygen is -2. So we have assigned oxidation numbers. If you want to find out the sulfate oxidation number, sulfur assume it to be X, and oxygen is -2 multiplied with 4, and which is equal to -2. So X value will be +6 we get. So make algebraic expression, so some of the expression if you make, then we'll find the X value, that is the oxidation number. Similarly, dichromate also, the chromium, if you don't know the chromium oxidation number, assume that it is X chromium multiplied with 2 plus, and -2 into -7 is equal to -2. So where X is equal to +6, we can get. So is the oxidation state of the chromium. So after assigning the oxidation numbers of each atom of the element in the molecule or in the ion, in step 3, so find out oxidizing agent in the ionic equation and reducing agent in the chemical equation, oxidizing agent and reducing agent. So after finding the oxidizing agent and reducing agent, and also find out change in oxidation number in oxidizing agent, as well as change in oxidation number of reducing agent we must find out. So find out oxidizing agent, reducing agent in ionic equation or in this redox reaction, and find out change in oxidation number of oxidizing agent, change in oxidation number of reducing agent. Let us look into this. Chromium. Let us observe the chromium. Oxidation number is +6. Okay. And in the product, chromium oxidation state is +3. Now, so change we can notice +6 to changing into how much? +3. Oxidation number changing +6 to +3. So electrons difference is how much? 3 electrons difference. So higher oxidation number to lower oxidation number changing, so by reduction. And similarly, sulfite ion oxidation number changing from +4 and changing into how much? +6. Now the change in oxidation number increasing, +4 to how much? +6, changing 2 electrons by losing 2 electrons. Now the sulfite is said to be reducing agent, whereas chromium dichromate is said to be oxidizing agent. Oxidizing agent. So chromium ions getting reduction, sulfur atom getting oxidation. So after finding change in the oxidation number in step three is over. Step 4. Step 4, what we have to do now, let me write equation. Cr2O7 plus SO3 minus 2 changing into Cr plus 3 plus SO4 minus 2. Yeah. So Cr2O7 minus plus SO3 minus 2 changing into Cr plus 3 and SO4 minus 2. So already the chromium atoms balanced, chromium atoms, chromium here 2 and this side 2. Now since oxidation number is changing plus 6 to chromium changing to how much? Plus 3. Electrons difference is 3 electrons. Whereas sulfur changing from plus 4 to how much? Plus 6. Changing the electrons number how much? So 2 electrons difference. Now balance this electrons number on both sides. So chromium gaining 3 electrons, but 2 chromium atoms are present here. So 2 chromium atoms, 3 electrons multiplied with 2. So then 6 electrons, and sulfur, one sulfur losing 2 electrons, and so it should provide 6 electrons. 2 into 3 and will become 6 electrons. So number of electrons are equated. So chromium gaining 6 electrons, together 2 chromium atoms. Sulfur 2 into 3. So here we must take 3 integers because 3 sulfide ions together losing 6 electrons to change 3 sulfate. Now sulfur atoms are balanced. So on both sides, then count the oxygen atoms. 7 into 9, 3 into 3, so 9. How much? 16. So here 2 into 3 plus 6, and so 3 into minus 2. So here charges on product side is already equal, but this side charges are not equal. So then hence this reaction is carried out acidic medium. So how much charge here? Minus 2, and 3 into minus totally minus 8 charges present. Hence I am bringing here 8 H plus ions for balancing the charge. So for balancing of the charge, I am bringing 8 H plus. So if I introduce 8 H plus, then but in the product side, so hydrogen ions are to be balanced. For this, I'm bringing 4H2O water molecules. I'm bringing because 4 into 2, 8 H plus. So hydrogen atoms are balanced. And oxygen atoms we can check 3 into 4, 12, 12 plus 4, 16. So oxygen atoms are balanced. The overall chemical reaction is Cr2O7 minus 2 plus 3 sulfide ions plus 8 H plus ions gives rise to 2 chromium plus 3 plus 3 sulfate ions plus 4H2O is the complete net. This is called net ionic equation. Net ionic equation. So net ionic equation. So you can check so all the atoms, whether the atoms are balanced or not. So this is the final equation, and in this equation, so chromium dichromate is oxidizing agent, whereas sulfate is reducing agent, because sulfur getting oxidation, chromium is getting reduction. So this is called oxidation number method. Thank you.